So the types, that is column matrix, row matrix, diagonal, scalar, identity, zero, null, everything is clear to you, right?
Yes.
Okay. So just a moment. Let's take one question and let's do it together. Okay, transpose of matrix and symmetric, skew symmetric matrix. That also you know, Kiran?
Oh no, we haven't gone through that.
Okay. Just a moment. Can you see this question over here, Kiran?
Question 21.
Yeah. Okay, before that instruction is added over here, that let's do it together. So here it says assume X, Y, Z, W, P. These are matrices of order 2 by N, 3 by K, 2 by P, N by 3, P by K. Okay, respectively, the orders are given over here. Now, accordingly, we have to choose the correct option. So the restriction on NKP, so that this is defined. The matrix multiplication P with Y, okay, added with W with Y. Okay, this will be defined when what will be the value. How can we do this type of question?
Um, I don't know.
Let's do it together. Let's discuss. So here we are having, here it says that P is a matrix. Okay. And what about the order of P? I'm writing a little bit of explanation over here. So X is a matrix, okay, which is having order 2 by N, right? Then
Yeah.
Y is a matrix. Order of that matrix is 3 by K. Then Z is another matrix. Order of the this matrix Z is this 2 by P. Then W is there, and the order of W is this N by 3. And then P is there. Order of P is P by K. Since here it is written that we have to take the matrix multiplication P with Y. When we are thinking about the multiplication between matrix, one condition is there which needs to be fulfilled. Do you know that condition, Kiran?
Oh, it, oh yeah, the rows, no, the columns should be equal to the rows in the other
Yeah.
matrix.
Yeah. So the column over here, number of column over here must be equal to number of row over there. That means K is equals to 3. It has to be there. Then only this PY we will be getting the result. Otherwise it will not be defined, right?
Yes.
Okay. So from here we are getting that K needs to be 3. Okay. The value of K has to be 3, right?
Yes.
Okay, now then added with, there is another matrix. We also have to say, like, if we are focusing on K value 3, then we can say that, yeah, option A may be 3. K is equals to 3. That is correct. Or maybe option C, right?
Yes.
Now here it says that W is multiplied with Y. So let's see the matrix W we are having, which is multiplied with Y. So the order of W is N by 3. and y multiplied with it. That means the order of y is 3 by k. Here also, the number of column must be equal to the number of row, which is already same. So this is fine. Okay, one more thing we can say, if two matrix are added together, okay, the resultant over here and the resultant over here, these two are added over here. That means both must have the same order, right? Then only we can add them. Do you know?
Yes.
Yeah. Okay, when we are having two matrix, both matrix must be of same order. Then only element by element you can add them, like a11 with a11 over here, a12 over there with a12 over there. Okay, this is how we do the addition, right?
Yeah.
One more thing we must know over here, that when we are getting the resultant of py, okay, that resultant of py must have the order that is p by k. Do you know that as well?
Oh, yeah. Yes.
We can take the row from there and the column from here. So p by k, this is the resultant of py. And what about the resultant of w into y? So we can say w was n into 3 and y was 3 into k. So the resultant over here will be n by k, right, Kiran?
Yes.
Now we are saying the resultant over here and the resultant over here needs to be same order, then only the addition will be possible. So p by k and n by k needs to be same. That means, can we say p and n are equal with each other?
Yes, we can.
Okay, so from here we are getting one of the option, that is the option number A is the correct option. Is it clear, Kiran?
Oh, yeah.
So these concepts was already known to you. Okay, let's do a few more questions like this. Just a moment. Next part says that if 7x minus 5z we are having, okay, then which one is the correct option? So x, let me write the order of x over here. X was having an order 2 by n. Okay, x was having an order 2 by n, and z was having an order 2 by p. Yeah. Okay, so here we have to say what will be, if n is equals to p, then the order of this one. Okay, 7x minus 5z. Do you understand that if we will do the multiplication of 7 with this matrix x, or scalar multiplication we are doing, so that will not give any impact on the order of the matrix, right, Kiran?
Yes.
Okay, still our matrix will be same, and 5z we are having. So if we will do the scalar multiplication of negative 5 with z, okay, still our order will be same, that is 2 by p. And if we will add this 2, okay, if we will add this 2, both the order needs to be same, right?
Yeah.
Okay, so 2 by n must be same as 2 by p. So p and n are equal, and what will be the resultant matrix order? So resultant matrix order, we can say 2 by n, or maybe we can also say 2 by p, right?
Yeah.
Okay, so we can say option B is correct option, right?
Yes.
Okay, now since you understand matrix multiplication, let's do this question. Just a moment, let me clear. Can you see the red colored part, the question?
We can.
Okay, here it says that there is a matrix A. Okay, where trigonometric terms are involved. So 0 minus tan alpha by 2. Okay, tan alpha by 2, 0, a diagonal matrix we are having. And I with the identity matrix of order 2. So I you can take as a 1, 0, 0, 1. So that this, we are supposed to prove that the left hand side is equals to the right hand side. Okay, let's do it together. So the given matrix A is 0 tan alpha by 2. Here we were having minus tan alpha by 2. Yeah. And here 0. Okay, and we are supposed to prove that the left hand side was I plus A, that is same as I minus A. So if we will do the calculation for I plus A, identity matrix just added with A, okay? Added with A. So what we'll be getting? I is 1001, right? Kiran?
Yes.
And A is 0 tan alpha by 2. Here we are having minus tan alpha by 2 and here 0. If we will add them, what will be the resultant matrix?
1 tan alpha by 2.
Yeah, minus tan alpha by 2,
And
0. Yeah. So left hand side, already we are having the output in hand. Now right hand side, we can clearly see I minus A, we are supposed to multiply with this one.
2
Okay.
2 will be A 2 2 will be 1, right? Or is it 0?
Oh yeah. Okay. 0 minus tan alpha by 2, 0. And this one 1. Yeah, it will be 1 over here. Yeah, A to 2 will be 1 plus 0 is 1. So the RHS, we can see I minus A. Here cos alpha minus sin alpha, sin alpha. So directly we can write I minus A directly if we are writing. So just 1 minus 0 will be 1. 0 minus tan alpha by 2. So here we'll be having minus tan alpha by 2. 1, here 0 is there and then negative of negative. So please check it. Are we going to have this one for this? Yes or no?
Yes.
Yeah, that we need to multiply with this cos alpha minus sin alpha. Let's do the multiplication. Cos alpha minus sin alpha, cos alpha. Okay. Can you please tell me what will be the elements over here? A11, A12.
A11 will be cos alpha
Hmm.
plus sin alpha. Right? Then A12 will be minus sin alpha.
Okay. So when we do the matrix multiplication, we multiply it row to column, right?
Yes.
Okay. So one we are multiplying with cos alpha, that is cos alpha. Then minus tan alpha by 2, we are multiplying with sin alpha, right?
Right. Right.
Okay. So when we are doing the matrix multiplication, so one thing we need to keep in mind that always we will follow row to column. Row to column. Actually, this chapter is when you will learn this chapter, you will think that it's really okay, simple. Yeah, it is. Okay, but towards the last, only one thing the student just get like a little bit time to recall how we were doing the multiplication, because this, okay, this is completely new process you are learning for the very first time. So one thing you must keep in your mind that always we do the multiplication row to column. Okay, when you are going in future after class 12 also, anywhere if you will encounter matrix and you have to do multiplication row to column, this okay thing must be there in your mind, then you will be able to get the final result. So we'll be doing the multiplication. So 1 with cos alpha will be cos alpha. Then minus tan alpha by 2 multiplied with sin alpha will be minus sin alpha multiplied with tan alpha by 2. Right, Kiran?
Yes.
Okay. Then the first row we will be doing the multiplication with the next column. Okay. And that will be the element A12. So 1 with sin alpha will be minus sin alpha.
Yeah.
1 with minus sine alpha will be minus sine alpha, and then minus tan alpha by 2 multiplied with cos alpha will be just the multiplication, because now we don't know what to do, right?
Yes.
Okay, so minus sine alpha minus tan alpha by 2 into cos alpha. Like this, we will be getting the terms tan alpha by 2 multiplied with cos alpha. So cos alpha multiplied with tan alpha by 2. Okay, then added with sine alpha, right?
Yes.
Okay, then tan alpha by 2, we can multiply with this one. So we'll be getting minus sine alpha, tan alpha by 2. Okay, and then added with this cos alpha. So basically, can you see, we ended up getting something, okay, completely trigonometric expressions as an elements. And in LHS, we are having this 1 tan alpha by 2, okay, minus tan alpha by 2, 1. So we must think that how to land to this LHS part from this, from the expression, from the matrix which we are having in hand right now, right?
Yes.
Any idea what can be done over here?
Actually, I don't have trigonometric questions, so I have no idea.
Trigonometry in your previous class, it was not there. Actually, this concept was there in previous class. Most of the curriculum follow trigonometry in the like first, after like
My
10.
textbook, we didn't have. Last time I learned trigonometry was in grade 10. So
Okay.
for 11th applied maths, we didn't have.
Okay, yeah, I have seen in your applied mathematics trigonometry. For now, it's not there, but I thought previously you have learned. Okay, fine. Let's keep this question, because here we need to trigonometry. We need to use the identities and the formulas. Okay, let's keep it as it is. Okay, let's take another question. Suppose this question we are having. Okay, the purple part. Please read it. Let if A are symmetric matrix and skew symmetric matrix, you have not learned, right?
I know the definition. I don't know its application and questions though.
Okay. Okay. So if you know the definition, this question we'll be able to discuss over here. If the given matrix is a symmetric matrix, then find the value of x. What can be done over here? What is the definition of symmetric matrix?
Um, Symmetric matrix means that when we switch the rows into columns, we
Yeah.
transpose. Sorry. If we transpose them, then the rows and the columns will be still the same.
Yeah. Okay. When we will just take the transpose, we will end up getting the same matrix. So yeah, we can use this concept over here, right, Kiran?
Yes.
Okay. The given matrix A is given as 4x plus 2, twice x minus 3, and x plus 1. If we will find the transpose of this matrix, which we write A transpose like this as well, or the other one A dash also we write. So if we are finding A transpose, the matrix will be 4x plus 2, right? Twice x minus 3 and x plus 1, right, Kiran?
Yeah.
And then we can do the comparison. After equating both sides, you will be able to create equations and then find the value of finding x, right, from there.
Yes.
Yeah. Okay, so I'm leaving this question for this matrix. Okay, so for the matrix, a matrix is given, find A plus A transpose. Let's find A plus A transpose. A we are having already, and A transpose will be able to find. So 2, 3, 5, 7 we are having, right? That is,
Yes.
and transpose will be, can you tell me what will be transpose of this?
Uh, 2, 5,
Yeah.
3, 7,
And when we will add them, what are we going to get?
4, 8, 8, 14.
Okay, this is what we got, A plus A transpose. And we have to check whether the resultant matrix which we have obtained, is that symmetric matrix? Is that symmetric? Please check it.
Mm, yes, it is, right?
Yes. Okay. So there is another concept. Okay. Till now you have learned that, like, when A is given, what is, how to find the transpose, and when, what is the definition of symmetric matrix when A and A transpose are same, that is symmetric. When A is equals to negative of A transpose, that is skew symmetric, right?
Yes.
Okay, after this, there is a concept that any square matrix can be represented as this. Okay, some of, we can write it as a symmetric matrix. When we will add A with A transpose, we will end up getting a matrix which will be symmetric. Always, any square matrix, for any square matrix, it will work. Okay, you take any square matrix. Suppose we are taking A as a square matrix 3 by 3. Here we are taking, suppose, 1, 2, 3, 4, 5, 6, 7, 8, 9. Random matrix I have taken. If you will add transpose of this matrix with A, okay, let's find the transpose. So we will be having 1, 2, 3, okay, 4, 5, 6, 7, 8, 9, right, Kiran?
Yes.
When we will add them, let's add them. Okay, A with A transpose, if we will add them. So our A is 1, 2, 3, 4, 5, 6, 7, 8, 9. And what about A transpose? It is 1, 4, 7, 2, 5, 8, 3, 6, 9. When we will add them, so 1 with 1, it is 2. Okay, 2, 4, 5, 6, 10, 10, 7, 3, 10, 14, 18. Okay, now this is the result of A plus A transpose. Okay, we need to check whether it is symmetric or not. Okay, so can you see it is symmetric? In symmetric matrix, your Aij and Aji are same, so you can check. Okay, this is A11, this is A12, this is A13. So A12 and A21, it is same. Can you see that?
Yes.
Okay, A13 and A31 are same. Similarly, this A 21, 22, 23. This is 2, 3. Okay, and A 3, 2. Can you see it's exactly same?
Yes.
Yeah, it is symmetric, right? Similar,
Right.
A minus A transpose, you take any square matrix. Okay, the next example or next question you can see, we are having just a random square matrix. Okay, and if we will find A minus A transpose, let's find it. So A transpose will be 2, 3, 4, 5. When we will do A minus A transpose, so A minus A transpose will be, our A was 2, 3, 4, 5. Okay, and subtracted with A transpose is 2, 4, 3, 5. Either we think it that we are adding and then minus 1, we are just doing the scalar multiplication, but directly also we can do the operation. So we'll be having 0 over here, we'll be having negative 1, negative 1 and 0. Okay, in skew symmetric matrix, Aij is equals to minus Aji. That is the definition of skew symmetric, right? So this is A11, this is A12, this is A21, and this is A22. And yeah, that is true. Can you see?
Yeah. Yeah.
Wait, then this one I have, this has to be plus because 4 minus 3 we have done, and is skewed symmetric we are talking, so it has to be the negative. Okay, when you will, this is the result A minus A transpose, but suppose you are giving it a name B matrix. Okay, a B matrix we are having, and we just want to recheck whether it is skew symmetric or not. That way we have rechecked. But if, okay, basic way we want to just check, basic way is B transpose must be equals to minus B, or B must be equals to minus of B transpose, right?
Yeah.
Okay, so let's check it. Let's check it. Let's find B transpose from here. So if we will find the transpose, we'll be having 0 minus 1, okay, 1 0. Okay, if we will take what was B, see, this was B. Originally this is our B, this. Okay, where we are having 0 minus 1 1 0. Here if you will take out minus out, can you see, we'll be having 0 minus 1 1 0, right, which is B. Getting it,
Yeah.
Kiran?
Yes.
Okay, so any square matrix can be represented in this format, that A plus A transpose will always be symmetric, and A minus A transpose will always be skew symmetric. Okay, given the condition that A has to be a square matrix. Now you will also encounter such question. Okay, we also have a diagnostic test, but I must tell you, since I have started, you will also encounter a scenario where, by using this is it possible that if we are having A plus A transpose, okay, and A minus A transpose, from there if we can generate A. Okay, so we will say that if we will take the half of A plus A transpose, suppose you are having one of the question where a matrix A is not given, but A plus A transpose is given to you. Okay, and A minus A transpose is also given to you, and you have to find A directly from here. One way is there to think about solving it, just like the algebraic equations, right?
Yeah.
Okay, another way is you can also do it this way, that 1 by 2 A plus A transpose. Okay, if you will add it with 1 by 2 A minus A transpose, just think about it. When you will open the bracket, it will be 1 by 2A, okay, 1 by 2 A transpose plus 1 by 2 A minus 1 by 2 A transpose. Okay, this gone. 1 by half A will be just A, right? Right.
Yeah.
So you can just do scalar multiplication, half over here, half over here, and you can add them, and directly you will land at A, right?
Right.
Okay. So there is another definition, that any square matrix A can be represented as sum of a symmetric matrix and skew symmetric matrix. That means symmetric is A plus A transpose, and skew symmetric is A minus A transpose. But we are doing half because we want A back. Got it?
Yes.
Okay, so these are the next few uh, concepts which you will be learning in your school, and here also we'll be discussing in detail. Today, yes, Kiran, we also have a diagnostic test. Okay, so I'm going to share the screen in your applied mathematics. Trigonometry is not there. Just let me share the screen. Few questions are there. And yeah, we are just trying to analyze the concept which will be needed in this class, class 12. Okay, every you have learned it in the previous class, and here also it will be required. So those concepts are clear or not? So there is just a very basic, okay, test is there. Please check it. Okay, this question paper actually it's not completely designed for you. Okay, it is designed for all the curriculum. So first let me ask you, okay, the concept which you have learned, that only you need to solve. Okay, you can see the question paper, right, Kiran?
Yeah. Yes.
So the first question is from set, and set is in class 12, right?
That's in class 12. Just a minute.
It's there in class 12, right? Okay, you are
I have it.
okay.
I don't. Yes.
Derivative you have learned in the previous class.
Yes.
Okay, then you will be able to find the derivative over here. This question 4. Okay, that okay. Let me zoom it. If the question is not that clear to you, it is 2 over x by 1 minus x square over 3x minus 1. Please do it in your copy and tell me the final answer.
This is first principle, right?
Okay, you are using first principle. The formulas directly you have not learned the formula.
No, we can we use the quotient rule?
Yeah, you can use first principle, but that will be huge. Okay, if we will use the ready-made formula, then it will be simple. So if you have used formula previously, you have learned how to use the formula, then we can go for it. Otherwise, we can keep this.
The quotient rule?
Yeah,
Is the quotient rule applicable in this?
question 4 from first principle.
Yeah, quotient rule for both of this.
First principle, no, it will be huge. Okay, yeah, you will be able to.
No, the quotient rule. There was one product rule and there was a quotient
Quotient
rule
rule,
for
you are
income.
saying, yeah,
Is it
exactly.
applicable?
Okay, yes. Quotient rule, product rule. Okay, these are the rule which will you can use. The here quotient rule is applicable. Okay.
So I just put that in minus, right?
Yeah.
Just a minute. Is the derivative of x 1 by 2x or 2 root x?
Derivative of this one.
Just x. 1 by 2 root x?
Derivative of there is a formula for x to the power n, that is nx to the power n minus 1 derivative. So if you are just having x, derivative of just x, it will be 1 due to like, according to the upper formula here the power is 1, so you will multiply 1 into x to the power. Here the power is 1, so 1 minus 1, that means x to the power 0 is nothing but just 1. Getting it?
Yeah.
So in general we don't show that much step. Whenever we have to take the derivative of x, directly we say it will be 1. From where? we understand that it came from the original formula. So yes, Kiran, for the first one, you have used the formula, the quotient rule that says that V, the denominator x plus 1, then the numerator's differentiation derivative, right?
Yeah.
That is
Is
0.
the for the first one, is the derivative x minus 1 over x plus to the power 2?
Let's check it. So x plus 1 to the power 2 will be having in the denominator, and here we'll be having 2 as it is, and x will be just 1. So yeah, here we'll be having minus 2 over x plus 1 whole square. Why? What about the other term, the bracket x plus 1? The bracket x became 1 and 1 became 0. Getting it? Derivative of any constant term is 0. Any confusion, Kiran?
Oh, no.
Similarly, we'll be doing the other one. We'll be taking the denominator as it is, 3x minus 1, and the derivative of x square. What is the derivative of x square?
X.
By
Let's
using the
just not. Oh, sorry, 2.
2x
2x.
to the power 2 minus 1. That means 2x to the power 2 minus 1. That means 2x, right?
Yeah, I wrote that here, but I didn't say that.
Yes. So 2x will be there and subtracted with the numerator as it is, then the derivative of the denominator. So 3x derivative, 3 we will keep it aside, x derivative is 1, so we'll be having just 3, and minus 1 derivative is 0, so just 3, and divided by the denominators square. After this, we can do the simplification and all, but at least for the very, like if we have to say the answer, if we will say only this much as well, then that is also fine. That 3x minus 1 multiplied with 2x, so we can do the multiplication. So basically, we'll be having this 6x square minus 2x, and here minus 3x square, right? Or divided by 3x
Yeah.
minus 1 whole square. Numerator, little bit simplification is possible. 6x square, 3x square is there. So we'll be having 3x square minus 2x. And in the denominator, let's keep it as it is, 3x minus 1 whole square. And here we'll be having minus 2 over x plus 1 whole square. So yeah, okay, I can see you understand how to find the derivative. Okay, just you need to just revisit the formula once. The concept is clear to you. Now, the trigonometry, that much you have not learned. Let me check another question which you can do from here. I have seen your syllabus here, matrices, determinants, and differentiation. Okay, calculus is there. Okay, differentiation is there, integration is there. Okay, differential equation is also there. So calculus properly it's there, right?
Yes.
Yeah.
Yeah, applications of it. Yeah, it's there.
Application of derivative, that is also there. So yes. I can see calculus properly, it's there. Matrices is there. Matrices you already understand. After that, if we need to discuss, and we can take the chapter determinants, right? Because in your school also, once the matrices, this chapter will be over, then they will take the determinants, right?
Yes.
Okay. So yeah, here also we can take the determinants and then we can pick the calculus, right?
Yeah. I think after determinants we have probability.
Okay, after determinants, they will be taking probability. So yeah, accordingly, the way the syllabus, when you are having the next upcoming exam in the month of April or what, the unit test or an
April 28th,
April 20,
28th of
and what are the
till 5th
subjects for that?
May. Uh, for applied maths, it's matrices, determinants, and probability.
Okay, so matrices is there, determinants are there, and probability are there. Okay, fine. So
Probability either half or full.
uh, yes, can you please repeat what you said?
Probability will be either half or full.
Okay, the full probability will not be there. Half of that will be there.
Mostly.
Okay, Kiran. So yeah, okay, I'm keeping this much over here. Properly, we have not started any chapter today. I thought I'll be discussing matrices with you, but I can see the concepts are clear from there and about to finish. Like you are about to finish the chapter because this symmetric, escape symmetric, it's towards the last. Okay, last concept, last few concept. So we are just, you are almost okay about to finish the chapter. Okay, next class we will see if anything, if any concepts are remaining over there, we can discuss that. Otherwise we can start with determinants as well. Okay.
Okay.
So yes, I'm keeping this much over here. Do you want to ask anything?